I welcome you all back to my YouTube channel. I'm back again with another interesting topic under physics, which is force. We are going to discuss what force is. We are also going to discuss Newton's first law of motion and Newton's second law of motion. So before we go there, first thing we need to know what force is. So if a question comes in an exam telling you to define what force is, you are going to say that force, this is a simple definition of force. Force is a pull or push. Force is the pull or push. So whenever we are talking about force, we are just saying this is a pull or push. Just these two things. So when you are pulling something or you are pushing something, that process we call it as force is being applied. So when you are pulling something, force is being applied. When you are pushing something, force is being applied. So there is what we call ability of force. Ability of force. So there are certain abilities that force does on a body. So one of the abilities is that force will change the size or the shape of the body. Force changes the size, so it will change the size or shape. This is what you need to know and understand. Size or shape of the body. So it changes the size or shape of the body. The second thing that you need to know and understand is that it will change the motion. So it changes the motion of the body. So these are the two abilities of a force. So once force is being applied on a body, it will either change the size or the shape, or maybe it will change the motion of a body. So it can change the size or shape. It can also change the motion of the body. So this is what you need to know and understand. So if you are new to this YouTube channel, don't forget to subscribe so that each time I upload a new content, you get to be notified. So now, before we go any further, everything in physics has got its specific SI unit. So the unit of force, is Newton. This is what you need to know. Is what is Newton? How do we write Newton? Capital letter N, like this. So the symbol is capital letter N. So this is the unit of force, which is Newton. So Newton is a unit of force. You know Newton is a what? Newton is a vector. So meaning force is a vector. So it is a vector. It is a vector. What is a vector? A vector quantity, this is a quantity that has got both magnitude. It has got both magnitude, so you need to know about magnitude. It has got magnitude and what? Direction. This is what you need. So force has got both magnitude and direction. Whenever we are talking about force, we are talking about a vector quantity, and a vector quantity has got the magnitude, which is the size, and the direction. So the other thing is that whenever we are talking about a force, this type of a force, is that the weight is a kind of a force. You know the formula for force. Let's say force, we say force is equal to mass times acceleration. This acceleration can be due to gravity, where we say it will also be force times what? Acceleration. Force will be mass times acceleration, like this. Then you know what weight is. Weight is equal to what? Weight is equal to mass times gravity. Because you know, by definition, we know that weight is a pull of gravity on an object. So the pull of gravity on an object is called weight. But force, we are saying that it is just a pull or push. So that pull or push, it is what we are calling a force. So this is some kind of a what? Weight is a kind of force. You know that force can be measured by a spring balance. So force can be measured by what? By a spring balance. Force is measured by what? Force is measured by what? A spring balance. So it can be measured by a spring balance. Also weight. Weight is measured by what? By a spring balance. These are some of the similarities that you need to note. Weight is also measured by a spring balance. So also measured by a spring balance like this. So this is what you need to know. This is what you need to understand. So these are some of the terms that I want you to get. These are some of the terms that I want you to understand. So force is measured by a spring balance. Also weight is measured by a spring balance. So we are saying that weight is a kind of a force. So whenever we are talking about force, there is something that you need to know and understand, which is a resultant force. So let us look at the resultant force. Look at resultant force. So there is more that you need to know under resultant force. So what you need to know, what a resultant force is that if two or more forces, so when two forces or more act on an object, they can be simplified. And this process is what we are calling a resultant force. So whenever we've got two or more forces, so two or more forces acting, on an object. So when two or more forces acting on an object, they can be simplified. They can be simplified. So they can be simplified. And this same simplification is what we are calling the resultant force. So whenever we've got two or more forces acting on an object, we can simplify that and come up with one force, which will be our force now, our final force. So let us look at an example. Let us look at, I'll say this is our example 1. Let us look at our example. So example 1. Let's say you are having a body. This is a body that we are having. This is a body. A body is like this. This is a body on a surface. So it is put on a surface. This is a surface. We've got a force that is pulling this side, which is 15 newtons. We also have another force pulling this other side. And that force is 5 newtons, like this. So we've got two forces that are acting on this body. So these are the two forces. We've got a 15 newton and a 5 newton. This one is pulling it this side. This other one is pulling it this side. So what we need to know and understand, in this case, you'll be told to find the resultant force. So you always be told to find the resultant force, because we've got, in this case, we've got two forces that are acting on a single object. So how can you find the resultant force? So the way in which you are going to find the resultant force is that, have you seen this one that is having a higher force compared to this other one? So whenever you've got two objects that are going in different directions, what you need to do is that you need to subtract their forces. So the resultant force in this case will be equal to, so the resultant force will be equal to what? You just need to subtract. So we just need to subtract, where we say 15 newtons minus 5 newtons. Then our resultant force will be equal to what? 10 newtons. This is what you need to understand. So these 10 newtons will be in the direction of this force that is going this side, because this is a higher force compared to this other one. So the final now, the direction of a body now, let's say this will be now a body like this. This will be a body. So it will be in this direction. it will be in what? It will be in the direction. So it will be in this other direction here. So this other direction that we are having here, which will be a what? A 10 what? 10 newtons. So it will be in this direction here. So this is what you need to know and understand. Let us look at another example. So this is your resultant force. This is how we get to calculate the resultant force. Let us look at another example. Let us look at example 2. We look at example 2. Let's say you are having a body. This is your body. This is a body here. So it has got, it is on a flat surface like this. It has got a force that is pulling it this side. Let me say that force is 8 newtons. It also has another force here, and that force I can just call it, it is I will say 5 newtons. I was supposed to write it there, but I don't have much space. I also have another force this side here, which is the force there, it is 15 newtons. Have you seen? So I've got how many forces? I've got 3 forces that are acting on this body, which is 8 newtons, 5 newtons, and 15 newtons. These are the 3 forces that are acting on this single body. So now, what are we going to do for us to come up with the resultant force? What are some of the things that we need to do? I've told you that if they are in different directions, you need to subtract. Meaning, if they are in the same direction, you just need to add the forces. So here, these two are in the same direction. So we add the forces that are here. We just need to add the forces that are here. So what is happening is this. This is what is happening. So the resultant force, let me say the resultant force. This is what is happening. The resultant force, which is here, is that you've got this. Let's say this is the body like this. So from here now, we've got this one that is moving from here up to there. This one is called, is the one which is a 15 Newton force. Then there is this force that is here, from here, which we don't know. But we've got these ones from here to there, we are able to tell. These are going in that direction. We've got what and what? We've got the 8 newtons. We also have the 5 newtons, like that. So this is what is happening. So now I want to find the resultant force. So the resultant force will be in that direction. Have you seen? Because you can be able to tell that even if you add these two, you cannot get the 15. So the resultant force will be in that direction. That's the direction in which the resultant force is going to be. So meaning the resultant force here, the final resultant force. So the final resultant force, this is a body. This is our body on the surface. So this is our body. It will be in which direction? So it will be in this direction like this. It will be in that direction. So these two are going in the same direction. So when we add these two, let's say 8 plus 5, what are you getting? You're getting 13. So the 13 you subtract from 15, what are you getting? You're getting a 12. Have you seen? You're getting a 3. So 12 minus this plus that, that is 13. So 13, you say 15 minus 13, it is 2. So that 2 is the one which is here, which is 2 newtons. And it is going in that direction. This is what is happening, and this is what you need to know and understand. So these are some of the things that you need to know. These are some of the things that you need to get and understand. Let us now look at another example, which is our example 3. Let us look at another example, which is our example 3. We look at another last example that we need to note. Let's say this is an object. This is an object. like this. It is on a surface. It is on a surface like that. So we've got forces. We've got this force that is pulling it this side. We've got these forces that are pulling it this other side. This is a 3 Newton. And this force that is here, this is a 2 Newton, like this. They are pulling it this side. We've got another force pulling it this side. This is a 1 Newton. We also have another force pulling it that side. That is a 4 Newton. So this is what is happening. I want you to see. This is our example 3. So this is our example 3. So this is what is happening. So what is the total force this side? These are in the same direction. So we just need to add what is the total what? What is the total force this other side? The resultant force. So the resultant force will be like this. This is what you are going to get. We've got this is like this. This is the resultant force here. So now if you they are going in this direction, these. So they are going in that direction. This is 3. This is what? This is 2 Newtons, like that. So these ones, also these ones, if they are going in that direction. Have you seen going in that direction? That is a 1 Newton and that is a 4 Newton in that direction. So if you check, if you add these two, if you try to add these two, if you add these two, let's say you add these, you are going to get 5. Even here, you are going to get 5. So what is happening is that the resultant force, if you check, the resultant force will be equal to what? If you add these two, let's say you add 3 plus 2, this is what you're going to do. Then you say minus what? 4 plus 1. You are going to get 5 minus 5, which will be 0. So you are going to get what? A 0 Newton. So 0 force. So this 0 force here now, showing it on a body, it will just be a body without any force that are acting on it. So it will just be like this. It will just be a body without any force acting on it. You know that the resultant force is 0 Newton. No force is acting on a body. So if the resultant force is 0 Newton on an object, then it is called, we call that as a force, forces are balanced. So we normally call that all the forces that are acting on the body are balanced. So this is what we get to mean if the resultant force is 0 Newton on a body. It is called that the force are balanced on the object. So these are things that we need to know. These are terms that we need to get. Let us now look at Newton's first law of motion. Let us look at Newton's first law of motion. These are Newton's first law of motion. This is what we are going to start with. So this law states that if all forces are balanced, so if all forces are balanced on a body, so if all forces are balanced on the body, there are two things that we need to note. There are two things that we need to know. The first one is that if it is at rest, it will continue to stay at rest. This is the first law, Newton's first law of motion. State that if it is at rest, it will continue to stay at rest. So it will continue. So it will continue. This is continue. It will continue to stay at rest. The other thing that we need to know under Newton's first law of motion is that if it is moving, let's say if it is moving, so if it is moving, it will continue. So it will keep moving. It will continue or keep moving, to continue or keep moving at a constant speed, at a constant speed in a straight line, in a straight line. This is what we need to know. In a straight line. This is what Newton's first law of motion states. So it states that if you are taught in an exam that state Newton's first law of motion, it states that if all forces are balanced on a body, if it is at rest, it will continue. So it is going to continue to stay at rest. If it is moving, it will keep moving at a constant speed in a straight line. So these 2 points are the 2 points that makes up Newton's first law of motion. So you need to understand this first one, that if it is at rest, it will continue to stay at rest. If it is moving, the second one, it will keep moving at a constant speed in a straight line. So this is all that we need to know and understand under Newton's first law of motion. And the other thing is that the property of a body that resists a change to its motion is called inertia. So I want you to know this, and I want you to understand this. Inertia. So what is inertia? Inertia, this is a property of a body that resists a change to its motion. That's what we call inertia. So inertia depends on the mass of an object. So whenever we are talking about inertia, it does what? It depends. So this one depends on the mass of an object. It depends on the mass of an object. It will depend on that mass of an object. So these are things that we need to know, that we need to understand. So if something has a higher resistance, let's say it has got a high resistance to change of motion, which means that one, it has a high mass, it is said to have high inertia. So this is what we need to get. This is what we need to know and understand. So let's make sure that we understand this. Let's make sure that we get what this principle or this law states. So let us look at Newton's second law of motion now. Let us look at Newton's second law of motion. We now look at Newton's second law of motion. So under this law, we are talking about unbalanced forces. So for every unbalanced forces acting, so unbalanced forces acting, so say unbalanced forces acting on a body, so acting on a body produces, so they produces an acceleration, so produces an acceleration in the direction, so produces an acceleration in the direction of the force, This is what we need to know and understand. So unbalanced force. So here we are talking about unbalanced what? Unbalanced force, a force which is not balanced. So unbalanced force acting on a body produces an acceleration in the direction of the force. Meaning that the acceleration, this acceleration which is being produced, there's this that you need to know and understand. The same acceleration that is being produced. So the acceleration that is being produced, that acceleration is directly, this is what you need to know, it is what? Directly proportional. It's directly proportional. So I'm going to do this. This is proportion. So it is directly proportion to the force. It's direct proportion to the force. So this is directly proportion to the force. But it is what? And inversely proportional to mass, and inversely proportion. This is proportion. So inversely proportion and inversely proportional to the mass. To the what? Inversely proportional to the mass of an object. The mass of an object. Of an object. This is what we need to get and understand. So this law states that for any unbalanced force acting on a body produces an acceleration in the direction of the force. Meaning that the acceleration which is being produced is directly proportional to the force and inversely proportional to the mass of an object. So in an exam, when you are told to state Newton's second law of motion, this is what you are going to say. You are going to say for any unbalanced force acting on a body produces an acceleration in the direction of the force, and the acceleration produced is directly proportional to the force and inversely proportional to the mass of an object. So inversely proportional to the mass of an object. That's why we say that force is equal to mass times acceleration. That's the reason why we say that. Meaning that the acceleration here, which is here, the same acceleration which is here, it is directly proportional to the force here. But when we make acceleration, let's say we want to find acceleration, we are going to say acceleration is equal to force times mass over mass. Force over mass. Meaning that the acceleration is inversely proportional. It is what? Inversely proportional. So it is inversely proportional to the mass. Acceleration is inversely proportional to the mass of an object, but directly proportional to the what? To the force. So it is directly proportional to the force, but inversely proportional to the mass. This is what we get to talk about. But the first one, the Newton's first law of motion, that one states that for any balanced force on a body, if it is at rest, it will continue to be at rest. If it is moving, it will continue moving at a constant speed in a straight line. So that's the first law of motion, Newton's first law of motion. So this is all that you need to understand. So the force here, the force which is here, this force that is here, this is what we are calling the resultant force. So it is called the what? It is called the resultant force. We call it as the resultant force. We call it as a resultant force, like this. It is the resultant force. Then the M, which you are able to see, that is the mass. So it is the what? It is the mass. That is the mass. Mass is measured in what? Kilograms. Then we've got the A there. What is the A? The A is the acceleration. So I just want you to have a knowledge on this if you don't know what I mean. A, it is the acceleration. So your A there, that's your acceleration. Acceleration is in meter per second squared, like that. So these are things that you need to know. These are things that you need to take note of. Let us look at one or two examples. And force, we've talked about resultant force, Newton's first law of motion, Newton's second law of motion. So let us now look at some of the examples that may come in your exams. So these are exam practice questions. The first example that we are going to get. This is the first example that we are going to answer. So the question is saying, a force of 300 newtons acts on an object of mass 15 kg. Find its acceleration. So we want to find the acceleration. So you know that force is equal to mass times acceleration. This is the formula which we know. Then if we make acceleration the subject of the formula, where we divide both sides by m like this, we are going to have acceleration which is equal to force over mass, like this. So this is the formula that we are going to use, where I'm going to say, so to get a simple data, which is given, I'm given a force of what? 300 newtons. I'm given the mass. What is the mass? The mass of what? The mass of 15 kg. This is the data which I'm given. So I just need to substitute there. What is the force? 300 newtons over what is the mass? 15 kg. Like this. I do this. Then I just work out the answer. So when you divide there, what answer are you going to get when we divide? So when you say 300 divide by 15, what are you going to get? We are going to get 20. So I'm going to say 20 meter per second squared. So that is the what? That is the force. So that's how you need to calculate the acceleration. So that one is the force. This is the mass. Then this answer that we found here, that is its acceleration. So this is how you need to answer these questions. This is how you need to answer them. Let us look at another question. Let us look at another example. Next question. This is our next question, which is saying a man pushes a 8 kg luggage on the smooth floor. It starts from rest and reaches 15 meters per second in 5 seconds. The first question, we are told what is its acceleration. So we want to find its acceleration. So this is a man that is pushing a 8 kg luggage on a smooth floor. It starts from rest and reaches a what? That velocity. So for us to find the acceleration, we are told to find the acceleration. So what you need to do, you just get the data which you are given. What are you given? You are given initial velocity. Initial velocity, let me not put that one. Initial velocity is what? 0. It started from rest. What else are you given? You are given the final velocity. The final velocity is equal to what? It reaches 15 meters per second. You are also given time. So time is what? What is your time? Your time is 5 seconds, like that. 5 seconds. Then what are you told to find? You are told to find the acceleration. Acceleration is what? That's the one that you are going to put that. So you find the acceleration. How can you find the acceleration? The formula that you are going to use is this formula where you say acceleration is equal to final velocity minus initial over time, because all the data is given. You cannot use that other formula because you don't have a force here. You don't have a force, but this formula can really help you, where you say this is equal to, what is your final velocity? It's 15 minus initial 0 over what is your time? Your time is 5. Then you say finally what is your answer? When you say 15 minus 0, it is 15. 15 divided by 5, you get 3. So it's 3 meters per second squared. This is what you get. So it is what? 3 meters per second squared. So 15 minus 0, it's 15 over 5. It is 3 meters per second squared. That's how you need to calculate the acceleration. So this is the acceleration which we have calculated. Then the next question, we are told to find the force. So we are told to find what is the force acting on the luggage. So B, what are you told to find? What is the acting force on the luggage? What is the acting force on the what? On the luggage. So want to find the acting force on the luggage. How can you answer such a question? So what you are going to do now, you want to find the what? You want to find the force. So you know that force is equal to mass times acceleration, right? You know this. Which is equal to, force is equal to, what is your mass? 8 times what is your acceleration? The one we've just from finding 3. So in total, what are we having when we multiply? It's 24 newtons, just like that. So that's how you need to answer it. It's what? 24 newtons. So this is what you need to do, and this is where we are going to end from. And if you are new to this YouTube channel, don't forget to subscribe to this channel. And if you are looking for tuitions in mathematics or science, you can WhatsApp me on this line. This is my WhatsApp number. You can WhatsApp me on this line. Then we'll be able to attend to you. This is my number, which is +26097066747. This is my number. You can call me on this number. You can drop a text. Then I can help you out with mathematics. If you are a GC candidate in 10 grades 10, 11, 12, I offer tuitions in mathematics, science. So science, I mean physics or chemistry. Thank you so much. Don't forget to like the video.